The BBC, a media conglomerate, was one of the first and early adopters of semantic knowledge graphs and the use of open linked data. We have the privilege to have both Max and Hans to tell a little bit more about that story, where they were, where they're going, and where they plan to be. Hey guys.
Great, thank you, and yeah, fantastic to be here. So what Max and I are going to do over the next half an hour is to really give you an insight of kind of like where we come from with linked data, where we are currently, and where we're heading in the future. So let me start off with a bit of history. So we've been looking at linked data for quite a number of years, and it was really back in 2010 when we thought it's like, all right, this is the moment where we're really going to look at actually building a product that's really powered by linked data. It was at the point of the World Cup, and we found that the kind of like ever increasing volume of just content, and in particular the ever increasing interconnectivity between the kind of like elements or items or content started to be very interrelated. And we thought we need to really start to harness this interrelationship and actually build much more richer audience experience, because it is really our mission to inform, entertain, and educate our audiences. So the strategy that we kind of came up with to evolve from this existing kind of relational kind of like content model and this kind of like more static publishing frameworks towards what we call a dynamic semantic publishing architecture. Before kind of diving into that, let's give the kind of like our statement of what we kind of really think linked data or how we use it at the BBC. So for us, it's structured metadata that describes our content and the things, the kind of like the people, the places, the organizations that the content is about. So what does that actually mean? So at the BBC, we generate a various different arrays of content. We have programs, we've got kind of like articles, we have TV and radio shows, and they tend to be about something. So let's just use the example of here's a program that's about Greta Thunberg. So if we actually then look at it for how our audience see it, here is the kind of the program called Fierce Women, and in this particular episode, it's actually about Greta Thunberg. There are others, for example, as you can see on the right, around Björk or Naomi Campbell. And again, it's just obviously a piece of content about something. Now you can take that a bit further, and we've got a bunch of articles, right? So when you go to our news page, you go to our sports pages, they're all kind of like articles. And again, they tend to be about something. So let's look at a case where Manchester United, a rather famous football team, we obviously have articles about them. So what we're starting to see, or in particular in the world kind of like cup case, we're looking into how can we build websites where the websites itself, rather than being kind of like this hard-coded kind of HTML and JavaScript and all the other goodness, is how can we express kind of like questions or queries at the kind of like page level that would allow us to dynamically kind of like film content onto the pages. So let's use this example here of give me the latest articles about a football team that is currently playing in a European competition. What kind of needs to happen underneath it in order for me to surface this? So the example that we use here is an article that we've created. It's reference. You can see a reference here to something called Creative Works, which I'll cover in a short while. But it's an article that we wrote. It's about kind of like if Everton will face Man United and West Ham, and what we're able to do as well is express another entity which kind of highlights that this is about an organization, and that organization is Manchester United. And actually, here is the kind of like the more open the DBpedia entry for Manchester United. So that would allow us to build a web page where the key is Manchester United and pull all articles into this. We've really kind of like started to look at this, like how can we use this to actually start to build like core navigation aspects around our website. So for example, the Premier League, kind of like our really big football league here in the UK, it's kind of like how could we build or write a query that really makes sure that all articles that are relevant to the Premier League actually start to appear on this web page. So what needs to happen under the hood is that the article that we just wrote, we need to infer a number of bits of information. So this article is about Manchester United. Manchester United competes within the Premier League. Manchester United is a type of team that competes within a competition, that be an overarching umbrella for Premier League and all sorts of other competitions. By us actually expressing these kind of networks, we can then really ask these kind of like really rich questions and allow us to build these kind of like navigational aspects on our websites. It was, as I mentioned, we started back in 2010 with the World Cup, and then back in London 2012 is where we were hosting the Olympics. We wanted to make sure we can kind of really build the best coverage on it. So that meant this kind of like initial concept around the World Cup. We need to make it more generic, right? Because Olympics pretty much has every single kind of like disciplines. There's nations there's individual athletes and everything. So how can we build a system that dynamically brings everything that we were producing at that time into one place and keep it up to date and accessible? So from this work, we really started to evolve a so-called sports ontology. Right, kind of as I was mentioning, that this kind of like ontology serves a number of different purposes. So we use it to navigate our website because you have really kind of like nice structures that you can follow. We have the ability to tag kind of like certain stories. For us, that's important because we tend to tag things within the news and the kind of like sports context. And it represents kind of like general competition because sport tends to be around competitions, and then allows us to kind of like drive results pages. So with those kind of like really key concepts, we were able to actually build these really kind of like rich sports websites. So here, to just give you a couple of ideas of what that looks like from an ontological perspective, we have obviously Rio 2016 in this example is a sports competition. The competition it actually relates to is the Olympics. There's a number of different disciplines that are part of that competition. It has, so it's an event in itself. Certain, we refer to them as stages, like the swim and men's for, and you can kind of see how these kind of like graphs start to evolve. So from this kind of like initial embark around the kind of like sport content, we then derived a whole bunch of principles and architecture patterns that I'll run you through now. Just to restate, so the linked data platform is our kind of like structured metadata to describe our content and the things, people, places, organization that the content is about. It very much is a RDF triple store and tagging. It really is that simple. Now, it isn't obviously, but on the kind of like really high level concepts, those two things are it. So what and how is tagging actually generated? So we have a number of different types of tags, and we have these forms that enable our journalists or data architects to go and create kind of like tags that we believe are relevant. This example we highlight here is David Beckham. You can see that there is a couple of custom attributes that we can add it, but we can also reference other tags. So that David Beckham is a footballer. So football is a sports discipline tag, which we can bring into here. And we can point to external places like his Wikipedia entry, so where we again could potentially extract some other information from. Those tags are applied in our content production system. So here, a journalist would log in, they would go and write their article, potentially put a bunch of pictures on it, and then they would use the right-hand panel to go and search for certain tags that they believe are relevant. And these tags, the core kind of goal and idea with them is to actually make sure that we represent what this piece of content that we're just creating, what it is about. We believe in the long term that's absolutely crucial for us to really go and understand what our whole content catalog is about. There's a number of other tools that we have in play as well. So what you just seen is the journalistic one, and this kind of like really kind of like highlights who writes and who reads kind of like from our triple stores. We have engineers and data architects that perform a lot of the management tools that need to, operations that need to happen, and then kind of like our audiences receive or pull from it through our various different products, may that be web or mobile. If we look at the application actually itself, it's separated kind of like twofold. So we have the application that read and write for particular kind of like tags. They release and they kind of suggest potential terms which go and write directly into our triple stores. However, the websites itself, they're all abstracted away behind some core like APIs that we have. So we have core APIs that deal with our kind of like news context. We have the music API that answers particular questions around music-related questions, and then the sports API that kind of would potentially serve things like which teams are in the Premiership, let's say in 2020 versus 2021, etc. So now that we kind of see the architecture, let's look at how we're actually modeling the data underneath it. At the highest level, we've kind of really have two concepts. We have what we refer to as creative works, which is the overarching kind of umbrella for any kind of like piece of content that gets generated. And we have this notion of things, and we actually call them BBC things, the things that we are of have special interest to us. So creative works is actually part of our ontologies. Our ontologies are published on the web. You can go to bbc.co.uk/ontologies, and you have full access to all the ontologies that we use underneath it. Creative works, as I mentioned, is the overarching umbrella. So that represents all of our news articles, programs, even down to things like recipes. The next thing is the BBC things. I mean, it's really hard to talk about things and things, but so things is really the stuff that we use as, or explain as rich metadata for describing the things that we're interested in. So here you can see the Manchester United tag that I've shown previously about all of the things that we kind of associate with Manchester United. What is a thing? A thing really is a unique identifier and a document describing that particular thing. It's available through an API. To give you an idea, we have roughly kind of like 32,000 things that are used kind of like actively, but there's a huge long tail of over 100,000 things in total. But you can kind of see there are like really core topics kind of floating about, and then in those instances, those things will just be used more and more. Creative works is then a document that really asserts that relationship between all of the various different things and the content. It's a really big driving force for all of the kind of like web or mobile when you navigate through our applications that drives this. And it's roughly in the kind of like 5 million creative works, although it's much more. Tagging itself is actually primarily human-driven, and we're starting to really look into how we can enhance that through some more automated tagging. We have two tag or classifiers. We have Mango, which is a classifier trained on Wikipedia data, and then Starfood, which actually looks at like past BBC tagging data to see how we can enrich them. I mean, these are really kind of ways of we have a video or a text article, can see what can we kind of like infer to that through Mango and Starfood, and then we present that to the journalist just to make that task a little bit easier, not to kind of like fully automate the tagging process. This is starting to get really quite interesting for us. So we can kind of almost see this as like, is this kind of like a knowledge graph building up? I've seen a couple of presentations before this one, so we're talking about this kind of like power of the graph, and we're really starting to see is like, right, within these individual domains, we're starting to build some really kind of like rich kind of relationships. And if you actually start to put all of these different ontologies or different domains together and see how the content is actually being tagged consistently, you can start to see how they can appear and kind of like match across the various different ontologies that we have. Here, just as an actual practical example, we have what we refer to as the ADA project. So here we were actually looking into when we create a tag that, for example, has a DPpedia or Wikipedia entry, can we pull additional information that is referenced on those pages to actually then again kind of enhance the graph that we have. So we have a radio for a show called In Our Time. In this particular example, the topic is around creativity. So let's see what else we have around creativity. What else is associated with that creativity tag? So we're now in our program page, and on our program page in regards to creativity, we've got all of these different programs. So let's say as a user, I go through this and I'm going to select oblique strategies. I can then kind of like click on that one, and that then takes me to that program page just for this, for the oblique strategy program. Here again, you can see it's like, all right, there's some related topics. Oh, interesting. Why is Brian Eno all of a sudden being associated here? So I can click on that and then go and see anything that we have about him. So we really hope that this enables our users or audiences to really kind of like make their own kind of like program discoveries through all of this data. So let me just quickly kind of like run through a number of kind of like where we're at currently. There's, as I mentioned, a number of different kind of like questions that we continuously ask ourselves. There's a huge amount of kind of like data that we're having in our stores. So 98 million trips and growing. We roughly run 45 million requests a day and growing, multiple different APIs, and we support a number of different formats. Kind of like bringing it all together and kind of like touching on this idea of the knowledge graph. So we do have this kind of like core concept of created works, and we then have these domain-specific vocabularies for sports, curriculum, and kind of like wildlife ontology. And I thought I just wanted to run through the curriculum ontology of what we've recently been doing, because this has been extremely important given the current kind of like lockdown situation. BBC Bitesize is kind of like our educational offering that gives kind of England, Northern Ireland, Scotland, Wales, every single one of those curriculums access to kind of content that we hold about those subjects. This kind of like really felt like a perfect match for this kind of more ontology, kind of like content related publishing mechanism. So here you can see the kind of architecture. We have, again, our linked data platform. We have the curriculum ontology. We have content stores where the content is being tagged according to that curriculum. We then have application APIs that bring this together and then present that on our webpage for particular kind of like resources. The ontology is as you can see here, has, again, kind of like various different classes, also a number of different properties, and we then enhance them with kind of additional information that we felt is relevant in order for us to make sure we build a really kind of like good user experience for students or kids at school to navigate. The editorial teams, again, do both aspects. They kind of like work and really define this curriculum vocabulary, which builds up the graph, which represents the curriculum as well as the kind of like navigations to the website. And then they also make sure they author the content and tag it appropriately so that it does appear at the right places. Once that's all there, they publish it, and then the kind of like website is generated. What we found, I mean, it's a real benefit of separating the data and the content. We really have a consistent description of that content, and there are unique identifiers to represent the things. Just makes it's like defining it once and then continuously referencing. I would stress, though, that where you're spending a lot of the time is actually making sure that your model is consistent. I mean, we are really much looking into how do we make the BBC more personalized, and with that come a number of different challenges for how do you actually model a user, for example, in an ontological sense. But making sure you spend the time there will really ensure that you have the right, that your experience, whatever you build on top of it, will just work really nicely. So on reflection, it's really great for strong correlation between metadata and content, where you've got something like sports or Bitesize, which is really quite structured. It has been really quite difficult that when we look at this more larger context of, right, how do you match football teams to educational curriculums, etc. That's still an ongoing challenge. It is specialized tech. You need to kind of hire specialists to look at maintaining your triple stores. How do you run a Spark code query? And also, kind of like, we found that our editorial team really wanted full control, right? If somebody wants to place something at a particular pixel, you don't want to build something that dynamically puts it there. So just as a case in point, here is an example of our BBC 3 homepage. And actually what started to appear is that there were tags that say, this is a homepage tag or this is a sidebar tag. This comes back to this idea that the real goal was, can we kind of like describe what the content is about? We felt that that's really important. But however, what's then resulted is like, what's the minimum amount of tags that I need to apply to a piece of content so I can still kind of like, as a journalist, ensure that that content then goes where I want it. So still something that we really kind of like need to find the balance. But on the other hand, what we are also experiencing is that we now that we have these kind of like tags, we can expose them to our audiences and actually give them the choice to really say is what are the things that they're interested in to really kind of like gain a more kind of like personal experience. But I'm now going to hand over to Max to talk a bit about what we're thinking about doing in the future.
Brill. Okay, yeah. So in the last 10 minutes, I'm going to talk a little bit about where our work on linked data might be going in the BBC. So I'll kind of cover some future-facing research and what this might mean, not just for internal systems, but what it could mean for a wider ecosystem of audience-facing applications and services. So myself and Hannah have both been working on a project to discover what the BBC's position is in the sort of what we call the new data economy. And what we mean by that is a sort of post-GDPR distributed economy of services. You know, things like data and data storage and identity and verifiable credentials, secure compute, all of that kind of stuff. You know, the re-decentralize of the internet, which is being driven by legislation, consumer demand, ethical concerns, which throws up all sorts of fascinating opportunities and challenges. There's 4 main pillars to this work, really. There's education, so improving the data literacy of citizens, which the BBC has obviously got a huge part to play in doing. There's data governance, so how we can lead by example, setting the best practices, but in industry and both in terms of technology and in ethics. There is the kind of discovery of what sort of new services we can create that wouldn't have been possible before in the old kind of world of monolithic systems. And lastly, there's technical research into what the platform needs to do to support this stuff. So central to our thinking and prototyping are personal data stores, chiefly the Solid project, which is held up by Tim Berners-Lee. And before I go into what a personal data store is, for those who haven't come across the term, it's worth a quick fly through the 2 broad problem spaces that have brought about the existence of personal data stores that we see currently playing out in all sorts of weird and wonderful ways on the modern web. So the first is, you know, the surveillance capitalism business model, which is becoming internalized, not just in tech companies, but it's pretty much every company on the planet now. You can't buy a vacuum cleaner that doesn't spy on you anymore. And these huge troves of data that are being collected now by every single product going have started to become quite dangerous. Like, as exemplified last week, you know, we had another huge data leak, which was the intimate details of literally every citizen in Brazil, which is going to have huge ramifications for decades to come. So there are a few individual companies that start to tackle, you know, this sort of problem, you know, in a sticking plaster kind of way, you know, the non-tracking search engines and tracker blockers for your browser and things like that, which I fully endorse. But the Solid PDS proposition is a little bit more interesting because it proposes a fundamental new sort of architecture and economy for the web. So that's one half of it. The other half, broad area, which is less to do with privacy and security and such like, it's more about consumer choice and the ability for developers to innovate. You know, as more and more platforms close off behind their data moats and shut down their APIs, you know, subscribing to the kind of data is money equation, it becomes harder for new players with better ideas to innovate. You know, you can't compete because you don't have enough data to bootstrap your service. So personal data stores are, the essential idea is decoupling consumer-facing applications from the data that holds them, and having a sort of more generalized approach to holding your data to allow people more control, a decision on who gets to see it and process it and under what terms, and also other services to come along and use that data in a more scalable way. Now, many new entrants to the market, you know, a lot of startups, some big tech players getting involved, and they've all got differing approaches to how they store data and provide access, what the processing environment is, if there's even one specified, what developer experience is, approach to ID, data semantics, business model, that kind of thing. But they're all fundamentally, I suppose, in the same game. What we've been doing is building a set of user-facing services and prototypes and a platform to support them. And this platform consists of 2 main parts, right? There's a personal data store side that I went through then. And we're using Solid for this. The reason we went with Solid in particular, it's essentially just about a set of open W3C specs. So you're not locked into a proprietary license or anything. You know, you can implement your own server if you want to, which works very well with the kind of open kind of universality principles of the BBC. It's all web native. So, and there's some really good JavaScript client libraries starting to come along. So it makes it very easy for our developers to get on board with it. I know one of the big hurdles that we often see in the world of linked data is, you know, most developers, they don't understand Sparkle or RDF or OWL. These are still quite esoteric concepts and aren't widely known. So if you can say, hey, just do some JavaScript, that ticks the boxes of the vast majority of the web development community. And having the linked data stuff native, you know, from the get-go, really starts to open up a lot of interesting possibilities further down the road, which I'll come to in a second. The second part is data exchange. So we recognize at the moment we're not in a world where every API is made available you know, as linked open data. So we need something in the middle to kind of do a bit of the heavy lifting for the client, caching, conversion, that sort of thing. So to bring this to life a little bit, I'm just going to run you through one of our prototypes to just show you how this looks to a regular user. They sign in with their kind of regular BBC account, the same thing they used to sign into our, you know, our existing services. Hit register, and they have a personal data store created for them, in the background. Then they can start to bring data in, right? So they can make use of it. So here in this example, we're bringing in stuff from Spotify, from Instagram, the BBC. So they say, okay, well, I want to bring in stuff from Spotify. They click that. They get a kind of a permissions page saying, okay, do you give this importer app permission to go off to Spotify, pull your data in and put it on your pod? And under what terms? They say yes. You get the Spotify standard OAuth connection. Comes back to the client, and what's happened now, this client app has gone off to Spotify, pulled back your streaming history, converted it into a sort of a more general purpose format, and put it on your pod. You can do the same, say, with the BBC, for instance. Similar thing, goes to the BBC servers, pulls back all your streaming history, saves it to the pod. And then this is where things get interesting. It then creates a sort of generic imprint of your taste, and you could easily see this scaling up to as many different media providers as you want. And you can start to use this generic media profile to start to power up other applications that might want to recommend you media. And because all the processing is done in the client, it's done in a way that means you don't have to give all of your Spotify data to the BBC, or the BBC have to give all its data to Netflix, etc., etc. So what we're looking to do now is we've built a kind of a first prototype recommender that uses this kind of this media profile footprint to give you recommendations around the BBC. So the effect is, you listen to Dr. Dre on Spotify, the BBC has no idea you like Dr. Dre because the data doesn't connect. But with this option, we might have like live sessions or like documentaries or those kinds of things that we could recommend and give to you in created streams based on other data. So if we now zoom right out and think about what this might look like on a global scale, we could have millions or billions of distributed pods, all containing slightly different variations of data to varying levels of completeness, which presents us with a few interesting problems that we might not have in a world where we only have to kind of concentrate on and be consistent within a single enterprise. A bunch of hurdles we're going to have to overcome. Getting the data, which is the first one, which is, we have GDPR, which allows people to get data companies hold about them, but it's currently a very slow process. A lot of friction. A lot of organizations don't want people to have their data really, so they make it available like in a PDF or some kind of useless non-machine readable form. Or it's, just that the back-end systems aren't built for giving all of a user's data back en masse. So things are slow and there's not very many standards. The other thing is kind of making sense of it, which is, of this conference. I mean, we've got 20 years of semantic web research behind us, a lot of existing good ontologies that we can start to make use of. We have Shapes, Shex, Shackle, whichever one takes your fancy, to help us choose which bits of which ontologies we want to use to kind of make use of kind of existing vocabularies and such like, and newer things come along like shape trees, which will help applications make sense of resource hierarchies with different sorts of data within them. The other big thing, I think, is how we do meaningful control of access, because we're outside the realm now of like internal enterprise or linked open data. We're in the world of personal data. So now there's a bunch of specifications coming along. There's web access control policies, and much newer shape masks, which will give us more granular control over various resources. We've also got from OAuth, the rich authorization request, which is again in draft spec, and ZCAP LD, which is like an object caps approach to authorization. Rather than having an access control list like many of these other examples are, you have authority by holding the right key, essentially, which might turn out to be a little bit easier to manage on a global scale. But even if you can figure out what the right protocol to use is, you've still got the UX, which I think is one of the biggest problems here. Like, how do you surface the power of these authorization protocols in a meaningful way that doesn't overload the user with like 1,000,001 different ways to, configure your data privacy options? And then what happens if they, click a thing and the organization that has given them the data contract doesn't do what it says? There's two schools of thought here. One is data trust. So could we have some kind of oversight body that takes care of your data on your behalf? Like we have trade unions that deal with employment law on our behalf and negotiate. Could we have people sign up to a giant data trust that can collectively bargain on our behalf? Or do we just delegate it to the courts. So in theory, everyone has their own personal data store. They have receipts of these transactions. At the click of a mouse, you could launch some giant class action lawsuit. Or maybe the answer is technical. I mean, I think it's both. You know, we have things like verifiable secure compute coming along. You could do everything client side and encrypt everything on the client. That brings with it a whole host of other things to get around. And lastly, how do we do machine learning if all our data is distributed and not on one system? Bunch of potentials here. You could do it federated machine learning, from Google, differential privacy, and much newer kind of homomorphic encryption. That's all we've got time for, I think. But if there are any questions, we will be over in one of the Q&A rooms very shortly. Thank you very much.